All right, so typically I'll go through some of the real basic functionalities. In 2022, really haven't changed that much. The interface itself pretty much has stayed the same. Most things have pretty much stayed the same. There really hasn't been too many big changes underneath that. There's a couple of weird things, but what I really want to do is jump right into the functionalities of what we have in 2022. So the first one here is in the surfacing module. And what it does here is it extrudes geometry now into a surface, or to a sheet, we call it. I call it surface, sorry. Old habits die hard. And this comes around because with WireEDM, although we have a macro that does this, I think it's nice to have it inside the product, where you can create some geometry and extrude it from within the product without having to do, some macro crazy thing like that. So basically, in the surfacing palette, you're going to notice a new function here, and it's called extrude. Pretty simple. We extruded this, and then you can quickly turn that into a solid by capping it. Okay, so that's one thing you can do. The other thing it does is you can do multiple shapes. So even if you had, 10 or 12 or 15 pieces of geometry, it will also extrude those, which is pretty cool. Now, keep in mind that these are connected. Okay, so they become, again, like a multi-lump body. And if you want to separate them, you need to use the solids, of course, here, the solids to separate them into individual pieces. Okay, so pretty simple functionality, but it's pretty cool. And remember, when you have a sheet like this that has, at the ends are planar, it's very easy to just go over here and say cap them off, and you can create solids pretty quick. Okay.
Steve, can you do this also with multiple geometries, not cylindrical geometries?
Yes.
I have tried this, no success. If you make the same geometry in blue with the offset, make an offset and try to select both geometries and try to extrude this. No chance.
Okay. Well, then the idea is probably it's a bug. And again, remember.
Only one.
Oh, interesting. I wonder why.
If you take circles, no problem.
Okay. Well, that's one that we're going to have to get turned in. Remember, too, guys, this is still beta, right?
Yeah, I know.
Hasn't been released. So, well, this is the thing, you got to keep the more eyes we have on the software, the better off we are. I mean, I can't test everything. I try. It's impossible. But this
I have find this at the same time as you show this functionality.
Oh, thank you for that.
Okay.
And that's your only question of the day. So, you got yours in, so no more. All right, well, we'll look into that. I don't know why that wouldn't do multiple shapes. Strange.
It might be some interaction with the nesting stuff that we've put in for solid extrude. But I'd call it a bug.
Yeah, okay, so there you go. So we got the right people on the call to see the problem. So we'll get this. I don't know if Luis is on the call or not. He's supposed to join us. It's really early out there. So thanks for the California guys being online.
I'm here, Steve.
Dude, you want to write that down? That'd be awesome.
I'm writing it down. We'll get together later about these. So
okay, perfect.
No problem. Okay.
All right, so that's that. Quick and simple, but it is pretty nice functionality, and it does work well. No, we'll get to that bug. Now remember, anything you find, please send it in to. Just go into. There is a beta email, right? I believe there is. We'll get that up.
Steve, it's close. What is the email? Those
There
beta.
is, but that's going to be shut down shortly as we transition into open beta.
So we're just going to go everything to support.
Yeah, everything goes to support next week.
On the 13th, I believe this goes to open beta.
Yeah.
So
So yeah, we can share the email address for the open beta, but
yeah,
or
just
the
wait.
closed beta, but just be aware that that's you know, only for this week. Is that still going to be connected to anything?
Okay, cool. Well, I would just wait till next week when it goes to open beta. And we can talk about the support thing if you guys want, because we're pretty much us application guys are pretty much involved with support now too. So talk about that at the end. All right, here's another interesting thing, and I have for this particular set of geometry, it actually works. I did turn in some stuff, so I do know there's a few bugs in this, but for the most part, it works pretty well. And so let me explain. So here's some geometry, and as you all know, I build a lot of sim files, and I do a lot of crazy stuff sometimes. And one of the problems, or I wouldn't call it a problem, is more of an annoyance, was that whenever I wanted to, let's say, take this piece of geometry here and build a sheet on it or surface for whatever reason, because for most of the sheet metal stuff, sometimes it doesn't come in right, and then I just, create a sheet and then extrude it into a solid. Well, in this case, I'd have to build a coordinate system here. Then I'd have to take the geometry, apply to that coordinate system. So all these steps to get anything done. Well, they since changed that in the fact that I don't have to do that anymore. As long as the geometry is not in the current plane, you can go up here, we can select the geometry, and you can see that it's in some skewed, and select the plane, and it will build a plane and trim it automatically. Okay, now so far I've got this to work in 99% of all the cases. I did find one which I've turned in that I don't know what was going on, but maybe it's just a bug, I'm not sure. But I can go through here now without having to, imagine having to create every coordinate system and then change the geometry, and it was a real pain. So this is very nice. So you can do this. And if you find something that doesn't work, please let us know. Like I said, I did find one file that, I don't know what it was doing, but it was something weird. But it was also a file that had, I don't know, it's like 4,000 services or something like that in it. So it was a big file, and maybe there's just something going on there. Okay. Questions about this? Again, these things are pretty straightforward, so it's not going to take me a lot of time. Okay, we're moving. All right, so, and I'm just going to follow the itinerary. I don't know if you guys got it, but I'm just going to go right down to the itinerary. Now, here's something that's really interesting, and this is something that they've enhanced, and it's called, for doing solids, for doing multiple extrusions, being able to pick multiple pieces of geometry and extrude them all at once. Let me do this, because otherwise it's going to look ugly. Okay, so if you didn't know this already, we're already able to do that. Most people didn't realize that we could actually do that already. The problem with it was you had to pick it in the right order. So everything was picked from the outside in, and it always worked, always. Okay, I'm going on my 24th year here. It always worked. The cool thing about what they've added or what they've enhanced in the solid extrude, the order doesn't matter anymore, which is very cool. So in this case, I can pick any order, inside, outside, doesn't really matter. And we can go in and extrude. Oh, I don't want to show that yet. Go ahead and extrude this. Into one solid, which is very nice. Very handy. Oh, that didn't work. Sorry. Very, very handy. Yeah. I think this is cool. I like this one a lot. So again, these become multi-lump bodies, which actually makes this really nice because now I can just subtract those from there. And again, you can still do single stuff if you wanted to do that. It all works the same. And you can build a part pretty quick. So this is a really nice enhancement to this functionality. Like I said, in the past, we could do it. Now the order really doesn't matter. You can pick any order in any direction. It's actually pretty cool. Okay. Questions there?
I noticed that when you did that it appeared that the circles were squares. Is that a matter of it not keeping the chordal tolerance, chord height?
Yeah, it was just set to like 100 thou.
I thought you just changed it though.
I forgot to apply it.
Oh, okay.
Yeah, I went up in here, some days, I just forgot to hit apply. I changed it, but I forgot to apply it. But yeah, no, that's just a chord thing, right? I mean, we could change it again if you really want to see it. See? So it just looks ugly when you do it that way, right?
No, it was just on the cylinders you extruded. Is what I thought I saw it that way, but
it did.
It
did. That's because I didn't apply the global. But
yeah.
Not a big
Okay.
deal because it always picks up on the one that you're saving.
Yeah.
So it really doesn't matter that much. More questions on this? Really simple stuff, guys, but it's really powerful. So if you're trying to get some stuff done quickly, this is really, really nice. Really saves a lot of time. And I'll provide you with all these files. I have them. You can see that I have them all numbered and everything, and we'll get them off to you. This is another nice little enhancement for extruding a solid, and that's being able to extrude it with taper in both directions. In the past, we could only do one, right? You could only go one direction. You couldn't go both. You can only go one direction. So now we can go in both directions, and you switch on taper angle, pick your geometry, and it creates extrusion up and down from that location there. Huh? This is also pretty nice functionality in the software. So this is new. You could only do one way, couldn't do both. So this is actually pretty nice. So a couple of nice solids improvements in the software there. Okay. All right. Don't have any questions? We're going to move on. Well, let's see. What's next here? Section view. Okay, this is a brand new functionality. And this allows us to look through a part, basically. What you're going to find up here, you're going to find a new icon that says Show Section View. So in the fixed floating toolbar here, I always find that humorous. You can select it, and it's hard to see, but right now I've come over this, and you can see that you get like a blue grid as opposed to the green in the profiler. So here, then we can just drag it, and you can see as I drag it through, it cuts through the part. So if you needed to see a location in the part that something isn't right, or you just want to see what it looks like, you can do that. You can also set the depth. So if you had a specific location or whatever, I'm going to pick this point here and apply. We'll go to that depth so that you can see, for whatever reason, maybe I need to see the exact, what does this look like? It also works in all the coordinate systems. So in any coordinate system that you have, it will work. So it's pretty cool. Again, you can set the depth however you want. You could even do this. Create a new CS. So like I said, in any coordinate system, so even here, if you have that angle A, I want to see what this looks like, or trying to make a picture or something that looks really cool. There you go. Okay, we'll talk a little bit more about this as we go through. There's a couple other things that it does that's I think is pretty sweet as well. Okay, questions about this? You guys are still out there, right?
Yep.
Just want to be sure. I've been having trouble with my internet, so if it goes out, someone needs to text me or something, but gotta make sure you're still out there. Okay, good. So that's that. Okay. All right. Let's look at this one. Is also pretty sweet. Again, if you, and I know some of you guys out there build machine sim models and some other things, and a lot of times aligning stuff is really painful. So this is a brand new function that at least it helps. Okay, it gets us in the game. So what I'm going to do is just, first of all, I'm just going to select this face and align that face to the CS. And I think we talked about this in our last session. How you can either pick it like that, or if you pick it again, it flips it over, which is kind of cool. So either way. But new functionality allows us to align an edge with a horizontal plane. So here I'm going to select this edge here. See that? I'll zoom in. Maybe we'll select this. It doesn't matter. Click that edge there. Right mouse click, and now we have a new choice here that says align to CSH. And if I click on that, now aligns that exactly with the horizontal axis. Now this is really slick. I really like this. At least now, this gets me in a location that I can move it around. I can do the things that I need to do with it without having to, oh, I got to draw some lines, measure it, this and that and the other thing. No, don't have to do that anymore. It aligns it up pretty nice.
But it's still creating history each move, correct?
I would say yes. Yes. Still creates the history with every move. Is that a problem?
It can be that the VNC file can get pretty big pretty quickly.
Yes. Yeah, I agree with you. I agree. But
and clearing the history doesn't always reduce you back to the original file size.
Well, if
You
it,
have
if it,
examples of that you can repeat.
Yeah, I was gonna say.
Workflow, send them in.
I'll see if I can find one.
Yeah, because I was going to say, because typically when you blow this away, I've taken files that are 500 gig down to 30 just by clearing the history. So, yeah, if it's not doing what you think it should be doing, we need to know about it, eh? And again, we're talking about, support issues here. So please, the support stuff's gotten a lot better, so not to worry. A lot of times what we're telling everybody, and since how I got everybody on the call, send it to support. You need our help. Typically what we really want you to do now is to send it in to support, get a case number, and then if you send one of us the case number, then we'll dig into it straight away. That's really what we want you to do. And that's how it's going to work. So some of the things that you might just send direct, send it to support. No, it's going to send you back a case number, I guess. I'll send us the case number and we'll dig into it straight away. That's how things are going to be working in the future here. Okay. All right. So this aligns it. Yeah, it does keep all the history. We haven't. I think that's a good thing. You can always go backwards. Okay? Questions? No questions? Jeez. All right. Let's see. Let's do this one here. This is another nice piece of functionality that got added in. And this is really, really useful. I'm just going to show you something really simple here, but when you get into 5-axis or you get into positioning, 3+2, whatever the case may be, this becomes very handy. So, as you all know, we have clearance volumes, and we now have a new button here that shows clearance planes and the clearance volume. So if you have clearance volumes in your MDD, you can show it by switching this on or off. If not, it will show you the clearance plane that you have set. So this is going to help a lot with collisions. Okay. This is really nice. And it is in the global clearance plane, so you can come in here and you can change it. Okay. So at least you have some idea of where you're clearing. And again, it's really more useful if you're doing, 3+2, or you're doing something pretty crazy, multiple part stations on a machine, or those kinds of things. It's become very, very handy. I mess around with it, and then if you have any questions, naturally, come back to us on that. Okay? So I want to show you one thing while we're sitting here, so we don't get too deep into this. Remember I said the section plane here thing, the show section, does other things. In fact, the other thing that it does, I'm just building another coordinate system here. So, is it cuts the toolpath as well. So it's a little tricky to grab it, but you can see that it's actually trimming the toolpath as well. See that? So if you had something that was really, really complex and you're trying to see what the toolpath looks like, you can actually go through there and drag it and go through the toolpath. So that's another really good functionality of this show section view, is it can actually cut through the toolpath. You could never do that before. So this actually is pretty cool. So real time. Okay. Cool. Questions about this?
Yes.
All right.
Yes.
Go ahead.
You hear me?
Steve, one item on the show section view.
Yeah.
Think of a complex part with deep hidden features deep within the part.
Yeah.
It would be a great capability to be able to select edges while we're in that mode. Think of controlling depth of a tool
Well, you could select
within a part where we just can't
right.
see anything.
You could select a face, probably. I would guess that I could select a face. Edge would be great. We'll put that in, but I think you can. You mean like when you come in here and you say, well, this is not a really good part, I guess.
Yeah, this is a simple part, so it's.
But I believe that if you wanted to set the depth here, and I could come in here and click on that face. Yeah, so you can at least pick a face. But we'll look at the edges thing, and maybe we can add that in there.
Yeah, the key is making it interactive with the tool pathing side.
Yeah.
So that we can actually get that selection. You run into some of these parts where features are just hidden deep in the part, and it'll save us a lot of grief.
Yeah.
Is
Okay.
the picking system not also interacting with the slice? Like, can you you're in face selection mode, right? If you click on one of those holes, will it pick it? Yeah.
Oh, okay. So
if your slicing plane hadn't been there, that would have selected the top surface of the part. So you can pick inside of parts with this.
Okay. All right. That's cool. That's why I was asking without actually having hands on. So thank you, Daniel. All right.
Yeah,
I'm
no
up.
problem.
Yeah. I picked the bottom of it. Yeah, that's what I thought. I figured you could pick faces, but I think what he was asking is, can we do the edge?
I don't know. Try it. I really do not know what's going to happen here, so give it a shot.
Steve, when
Yeah.
you create a pocket toolpath, can you also use the section view to trim the toolpath?
You can't pick the edge. Oh, yeah. Sorry. One thing at a time. So you can pick the edge. Looks like you can pick the edges as well. Look at that. So it leaves the edges up on the screen. I just learned something here. That's kind of weird, but it's doable. Okay, hope that helps you, Jeff. All right, go ahead, Thomas. What? Again, what was your question?
Yeah, that answers it, Steve.
Okay.
Yeah, we'll play with it from here.
Yeah. Yeah, just let us know. You know, there's a lot of really interesting things you could probably get away with. I know one of the questions that had come up in the past about this especially about the section view thing, is being able to use the profiler with it. You know what I mean? And that would be another cool thing if we could snap the profiler to that position, because that's kind of what some people are going to want to do. For now, you would, whatever you typed in as the value that you move this to is what I would just come in here and do the same thing with the profiler, and it works. The one extra step, at least it works. Okay.
Looking at having a transfer button that'll let you send the depth back and forth between those.
Yeah, that'd be cool. Be cool. But again, you know, for now we just need that's the simplest way to do it. You know, just remember the number or copy and paste it in, and it works okay. And you might not want that. Maybe you just want visualization. It just depends what you're looking for. Okay. Any more questions? More questions about this? Clearance thing is cool. Play around with it. It's actually pretty neat. You have multiple part stations that will show you different heights and all kind of crazy stuff. Maybe at the end I'll bring up a file and I'll show you how it looks in real life.
It's
Okay.
actually a really neat tool to understand how GibbsCAM clearances work even. I mean, I think a lot of people don't necessarily have it directly in their head how, say, legacy mill turn clearances work, where the mill tools are clearing to a plane that's in contact with the can and that sort of thing. And this will show you how each op is clearing. So it'll show you how the mill ops and the lathe ops are using slightly different clearance mechanisms on a mill turn part.
Yeah, very cool.
And similarly on a straight mill part, how you know, the clearance plane is dropping for same tool ops and that sort of thing.
Yeah, it's very useful, and I've been using it a lot. Okay. All right, moving on. This is another nice one, and I was getting this complaint a lot, and I think we have the solution now. One of the interesting things here is that people want to do multi-part, right? Now the problem with it, well, it's not a problem. It's just how it is. You have a grid of parts like this, and this was a huge complaint that I was getting a lot. If I go off and I start to machine it, okay, and this could take, if you had lots of little parts, which I had one customer who had lots of little parts, take hours to go through all of this stuff to check to see, hey, did I get it right? You know, and so this has been an ongoing issue. In this version, we have a new icon here that says show multi-part. What does that mean? Well, right now it's on, so it shows the multi-part. If I click it off, it only shows one part. So now I can go in, I can machine it, I can do all the things I need to do without having to render the whole entire group. And this is very nice. It works the same way with tombstone management as well. So if you wanted to turn off all the parts while you're rendering, you can, and render one part, get it right, switch it back on, and then if you want to watch the rendering for all the parts, you can do that. I think this is really nice functionality. Okay. Any questions here? Really simple stuff, but I think it's very powerful. I'm also going to mention this to you guys. I ran into this the other day, and I'm not sure if he's on the call or not, but I'm going to use his example. We had a customer showed an OpSim rendering in like 3+2, and OpSim showed perfectly. However, that wasn't the case. The tool actually ran through the part, and I said we'll just use MachineSim. And to my surprise, as many people didn't know this was in there as well as myself. I'm going to and you might know this, but I'm telling you, if you're doing anything with 3+2 or any kind of positioning, I would go up in here, and you see there's a checkbox here that says skip interop moves. And that by default is checked. So what that means is if you're moving from an A rotation somewhere else, it's not going to show that if it runs through the part. It's not going to show you that. Okay? But if you switch this off like this, if you turn it off, the check mark off, it will. And it could save a lot. So I just want to mention that to you because it just happened to me and I didn't even know this was in there. And I talked to several other people and they're like, oh, really? No one. So some of these things are a bit hidden. But please, if you're checking that kind of stuff, especially if you're going to use OpSim and not MachineSim, because MachineSim will always show it to you. It's actually disabled in MachineSim. But if you're not, if you're going to only use OpSim, I would switch this off if you're really doing positioning kind of stuff. It will show the tool run through the parts. At least gives you an idea that, hey, this.
So why not default off?
I've asked that for that enhancement.
So the reason is that OpSim is to simulate ops. It's not to simulate the interops. And particularly on generics, the interops are bad. So the interops that we know about have the tool transferring through Z0, for example, which might be inside your part.
Right. And it's always been like that.
If you have a specific MDD, then you'll have better luck with this. But a lot of people don't. So
a lot of people don't, right? And that's how it used to be, Daniel, right? Back in the day, we didn't have this, so it always showed you the part coming from the middle of the stock. Always showed that, always. And then at one point it just went away, and this is why. But all I'm saying is that it is useful. So like Daniel says, please take his advice as well as mine. If you have your own MDD, please, I would turn it off, especially if I'm doing 3+2 using the ops. If you don't want to use sim, I think it's
if you're not planning on using MachineSim. So MachineSim will always show you everything.
Right.
And that's really if you want to see that your whole program is clear of everything, MachineSim is the way to go.
Right.
OpSim is really about how is this working for this particular op, because there is some value in, for example, being able to collision check a particular op without having to worry about whether your interops are clear. If all you're working on is the toolpath right now, there's value in that.
Right.
It's also worth noting that the show clearances is active for OpSim. So you can see for each op where your clearance plane is. And on his particular part, if he had that active, he would have seen that clearance plane cutting right through the middle of his part.
Right, but that
would have been a dead indication that there was something wrong. And yeah, he wouldn't have seen the gouge because we wouldn't have shown that move, but he would have seen that clearance plane in the middle of his part.
Right. Unfortunately, that's in 14, so.
Exactly. Well,
all I'm saying is
use the new features as well as the old features.
Yeah. All I'm saying is I learned a lesson, and I just like to pass that on. That you don't have to do it that way if you don't want to. Again, I think sim is. I agree with Daniel that sim is the best way to do it. But if you don't have that option or you don't want to do it that way, just be aware that there is a way that you can actually show it when it's positioning. Okay. So that's the only thing I want to say to that. Okay? All right, so I think there was a question about, and I hate to digress, but I think there was a question about what if we had pocketing, right? Somebody asked me that question about the, so I think it was Thomas there. So yes, the answer is yes, it will go through, what's going on here? It will go through the toolpath, any toolpath, I believe. Right, Daniel?
That's correct. In any toolpath that intersects it will
Will be trimmed out. That's actually very cool. Again, it's a more complex toolpath, and especially for some of you guys that are doing 5-axis, this could be pretty sweet.
It can be pretty helpful for volume L2, where with the slices aren't all identical, so you can look through kind of one slice at a time what it's doing.
Okay, we beat that to death. All right, moving on. Now I'm gonna do. Sorry, Andy, but I think we talked about this. I'm just gonna do this quick MTM thing. For Andy's gonna do some Swiss stuff after a while, but one thing we added for MTM, actually there's two things we added for MTM. One's a bit difficult to show, the other one is not. So I'm going to zoom in here to this toolpath, and let me get in here, and I'm going to redo this just so you can see the difference. So here's just a normal toolpath, what we would have. Notice on these square corners here, it rounds the corners always. It means we've always done that, okay? In the dialog now, there is a checkbox for square corners. So if you didn't want that to be a small radius, it will make the corners square. Pretty simple, but I guess a lot of people have been asking for that. And I don't know, and if you wanted to comment on that, but that's one of the things that is new in this version. Okay, so that should help the turning guys out. The other thing, here we've added with start at operation. Okay, so we could always start at operation, and Daniel just clarified this for me last night. It now works in all the flows, right, Daniel?
Yeah, so previously that would have been disabled in multi-flow situations. So
that's been changed. So give it a go. I haven't actually given it a shot yet. I don't know. Have you, Andy? You're out there, I hope. I have not given this a shakedown. So
not yet, but I definitely will.
Okay, good.
And that uses the material state in order to basically it'll start by using the material state at the previous sync from the operation you've picked.
Yeah.
So it's actually substantially faster than it used to be, as well as letting you start in some more places that you couldn't start before.
And in fact, I use this all the time now, even for milling stuff. I switch this on now all the time, because if I'm doing something in an area that I just can't seem to get it right, I'll switch it on, and it actually is really good, and it's fast. In this version, it is really fast. So be aware of that. This actually has really been, some of the performance of the software has actually been enhanced a little bit, and actually is much better than version 14. So use this. It's actually pretty cool. Anyway, I just want to mention that. It can't really show it. I guess I could show it, but that's good enough. Okay, any questions about the square corner thing? Pretty simple, but if that's what the customer wants, you can get it. Okay? All right. I'm going to, let's see, do I want to do that? Yeah, I'm going to jump around here a little bit. All right, let's look at something else here. I'm going to jump around here, and some other thing that's been added here. Let's see, where did it go? We are. Okay, so for contouring now, we've added pre-drill. Okay, and it actually works. Now, we could always do this with solids, but not so much with geometry. And it works with open geometry, all kind of things. I just want to show this because I think it's interesting how it works. So I'm going to come down here, and here we'll just create a process. And this is nothing fancy here. We're just going to use the same that we'd always use for anything, right? For any kind of drilling process, you know. We could set some depths, but I'm good enough with that. And then we'll come here and we'll set the contour, and we'll give it a depth, I don't know, 1 inch. And this is always a little tricky, but okay. All right. So now what I want to do is just pick the geometry. Now, what's interesting about this is it's going to try to put the start hole at the geometry that you picked. Okay. So I'm going to pick this circle, and then I'm going to pick this line here. You know, pick that line there. You know, pick that circle. Maybe we'll pick that one. I'll pick that line. I'm just going to go around here and do this, and hopefully this works. And there you go. Okay. So notice that it pre-drilled all the holes. See that? Very cool. All at once. Very nice. But what's also interesting, and I don't know if this is by default or just by luck, but if you notice, I picked this radius, and that's where it started. That's where it drilled the hole. I picked this line here, and you'll notice that that's where it starts. So it drills the hole here, and it leads on at that piece of geometry. So it's pretty smart, and it actually works really well. I really think it's a pretty good enhancement to the software. Okay? And it does work on outside geometry. So if you had something that was just a piece of geometry, we'll drill the holes on the outside. Why you would do that, I don't know. I guess, I don't know. Maybe you wanted to clear something close to a part or whatever the case may be, but it will do that as well. So this is it's a pretty nice enhancement, I think. Any question about this? Okay. I'm just going to keep going here. I really want to get to the 5-axis stuff. That's the stuff that's really you know what, let's go back to this because I guess I didn't put a part in there. Not to worry. I'm just going to show this because it was hard to actually get something that made it look reasonable. So with VoluMill, the enhancement for VoluMill is to improve where you want to start. I mean, you guys can mess around with this on your own, but right in here, they've added something where you can actually define or hope that it starts in those areas. I've messed around with it a little bit, and it works okay. But I think it's a guess. That's my opinion. It still does, you know, the volume kind of stuff, but at least this gives you the ability to say, hey, I really want to try to start in this area. And it does work in some cases.
Yes, this is basically a suggestion to VoluMill that you would prefer it to start on that side if it's otherwise equal.
Yeah. Advanced 3D has the same thing where you can set a plunge point, but it's kind of a recommendation. It's not. It may not go there. But
so VoluMill is always going to pick an optimal start point for the pocket. It'll be the one that clears the pocket fastest. But there might be more than one. And if there's more than one possible optimal start point, this will suggest which one it should be using. If you have a pocket that only has one optimal start point, then obviously you're not going to see any result from this.
Yeah. Yeah, and that's one of the things that I think that, again, this is just my opinion. VoluMill does a pretty decent job. So unless it's some really weird shape, it usually does a pretty good job picking where it needs to start. but you never know.
This is particularly valuable if you have like a part that has a bunch of slots in it and you want to start all the slots on the same side instead of having it randomly switch back and forth. This is really good at controlling that.
Well, cool. I'll put a part together with slots. Okay.
Is
That's,
custom is
ahead.
custom the ability to pick a point or no?
No, it's an angle.
Oh, an angle. Because one of the things that
So
we
you're
get
really suggesting please start towards this side of the pocket. It's not at this position. You can't pick a position.
Okay.
Because volume always has to start at an optimal point. And so that optimal point is going to be determined by how far it can spiral and a few other things. And so that's all coming from the toolpath engine. But like I said, there might be times when there's more than one possible optimal point.
Yeah, I get a ton of requests for being able to just pick a point because you can drill a hole with a carbide insert drill a lot faster than you can volume mill down. And I get that request all the time to, hey, can I drill a hole, plunge down to the bottom, start volume milling?
Yeah, so use pre-drill for that. So volume mill is connected to pre-drill. If you're using the Helix plunge type, make sure you're using a drill that's big enough. It can't just be bigger than the tool like all our other processes. It has to be about 50% bigger than that in order for volume mill to pick it up.
Okay.
But pre-drill does work.
Right.
Dave, you can also, you have to use geometry to do this, but you can have the geometry of the pocket, and then you can draw a circle that is the diameter of the drill and make it air, and volume mill will recognize that and try to start in that hole, like Daniel said, if it's big enough.
Okay.
Yeah, the pre-drill stuff in volume has been there forever.
Yeah.
Right?
Yeah.
It's been there for a while.
The thing to be aware of is just that it is really picky about how big your drill is.
Yes.
Right.
So don't be using a drill that's one drill size bigger than the end mill.
Right.
It's not going to work.
Yep.
It's got to be a lot bigger.
Mm-hmm.
Okay.
But let me go back
thank you.
and yeah, Dave. Let me go back in my notes because I know we put this in. I'm not sure what version, 10 or 11. Let me go back and look at my notes because there is a specific. I remember there's a specific kind of thing that, like Daniel said, that you have to have. I don't know what the percentage is off the top of my head.
Okay.
Can't remember what I did yesterday half the time, but let me dig back through my notes and see what we're saying it has to be. I'll get that off to you.
Okay, appreciate it.
Yeah, no worries. Yeah, but the pre-drill for volume has been there for, I think, it was version 12 or 11. I think we put it in there. Here's the problem with the software these days is that there's so many things in there nowadays. It's really hard to remember, some of the things that are there. So.
Well, and if you pick the wrong drill size, apparently all bets are off. So
it's really easy to think that volume mill doesn't support pre-drill if you're following the same rules as the rest of the software where you're just using a slightly bigger drill and just dropping the tool into it.
Mm-hmm.
Basically, volume mill needs to be able to helix through the hole that you've drilled freely. It can't just plunge down it.
Okay.
So it needs quite a bit more space. But if you're using a 1.5 inch drill for a 3/4 inch end mill, that's fine.
So it's still going to helix?
No, it will trim out the helix if you pre-drill.
Okay.
So it's aware of the pre-drill. It will choose the point. It'll drop your drill down, and then it will plunge into the hole until it has to helix. So like if you have a tapered drill, it'll helix the bottom out.
Okay. It's good to know.
But because it's going to do that, it has to have enough room to hit the entire helix all the way down, so it doesn't over-engage.
Okay, that makes sense.
Even if you're using a flat bottom drill. So it might seem like you could use a smaller drill, but you can't because of the way its logic works.
So the toolpath is calculated as if there is no hole there, right?
Yes.
And then from that hole, if there's any geometry within that hole, that wouldn't contact material, then it just trims that toolpath out. That's the way to think about it.
Yep.
Well, thanks, fellas.
Yeah, no worries. Oh, anyway, so this is just another way to suggest, hey, I want to have everything start in this quadrant, as it were. And there is some performance, I believe, some performance enhancements as well. Okay? Questions? All right, so now we're going to get into one of my favorite things that I've been messing around with. And here we're going to talk a little bit about it, and Andy's going to talk a little bit about the Swiss part of this. But I'm going to start with something that's brand new, and I think that this is really, really useful. And I'm going to go through here, and we're just going to make your lives a bit more complicated. But that's okay. That's what we're here to do. And we'll talk a little bit about this. All right. Now, I'm using this part because it's cool, not because I like to do screws with the A-axis. So I'm just let's just be clear on that. When you guys send me these kind of files, I always say run away, but this looks cool, so that's the reason I'm going to show it to you. One of the enhancements that we've made in simulation in the kinematics is something called configurations. And what does that mean? It means this. Let's say I have a simple machine like this that, oh, and I can turn on the clearance plane too. You can see that. You can see all the stuff that we've been talking about. Let's say we have a simple machine like this, okay? And as we all know, a lot of these types of machines, these fixtures, as they were, this rotary table, it's added after the fact. Or, hey, I don't use this every day. I might use it once in a while. But I want to be able to use my machine. And in the past, what we need is 2 MDDs. That's what we need. There's no question about it. You had to have an MDD that had no fixturing, and then you had to have an MDD that has the fixturing, which presented a lot of different problems. Well, not anymore. What configurations allows you to do is build an MDD with multiple configurations. And what I'm going to do is just kind of show this to you. So you see this, yeah? Okay, so here's a machine, got a rotary table and a part. Now this part naturally is not good for just a flat table. But in the document dialog, what you're going to find when you have configurations in your MDD is a tab called configurations. And here we have, in this case, I have 2 different ones. I have a rotary one and I have a fixed table. If I switch this to the fixed table, for example, completely changes everything. If we look at the sim, we now see no more fixturing, and it now becomes a regular mill. You can put, you know, flat parts on there, bites, whatever you want to do. You'll also notice that I had an MTG in here, and that actually gets, you know, knocked out because it doesn't belong to this configuration. So this is a very, very cool, and it's a very powerful. Okay, so for these simple machines, it's brilliant. Okay. As we get into more complex stuff, and Andy's going to show you something on the Swiss machine, very, very cool. Now, with that said, the bigger question then becomes is, well, gee whiz, well, how do we set it up? So let's take a quick look, because there's a couple other things in the MDD I want to show you guys anyway. Let's open up this MDD so that we can see it. And this is for all of you guys who do this kind of work. Okay, so basically we have our generic, and down here now, as we go to build, we have another choice here that says add a configuration. So we would add a configuration, and then under this, I'm going to add a configuration group, and that's what this is. This is a configuration group. And basically, this is where I put in all the things that I want in that group. In this case, with the tailstock, as you can see, I had thought to myself, and again, I try to think about what the end user might want. That's what I try to think about anyway. And in my experience, these components aren't usually set in the same spot every single time. They're usually all over the map, right? So what I did here, when I built this, I built these at 0. So it's the center of the machine, the center of the table, over the center of the spindle. Because the MTG allows me then to move these wherever I need to move them based on the part size. Okay? And a lot of times guys already know what this is. They might measure from the back to the edge of the table, some value, and then you can move the thing around in the configuration or with an MTG. So that's why I have an extra linear axis here, and that helps me move this stuff around. And then, just added the different bodies. And then you have the rotary, the A-axis, where the part station is. And I wanted to talk a little bit about this. One of the enhancements in the MDD now is to allow us to do cylindrical or part defined. So if you click on part defined, what that means is in the document dialog, you'll have a choice now whether you want the stock to be cylindrical or rectangular or square. And if I'm not mistaken, Daniel, this only works in milling, right? It doesn't
That's
work
correct.
so you can't have a square stock in turning. It only works for milling. So
Yep.
even 5-axis, anything. So if you want to define whether or not you have a round part or a square part, you can set that now in the MDD. It doesn't have to be with configurations. This is separate from configurations. It just happened to be that in the part station, so it doesn't matter the part station. You can set it to be whatever you like. And that's basically it. Okay, so this is one group, and then this is the next group. So this one here is the fixed table, and this one doesn't have anything. It just has a part station. That's it. Now I could put a bison there or fixturing or whatever, but in this case, it just has a part station. Every one of these configuration groups needs a part station. Interesting thing about this, for those of you who write MDDs, is that notice that the part station is the same, part station 1. Because it's completely separate from each other, we can do that. So I would guess, and I haven't done this, and I just thought about it now, you could probably have multiple part stations inside of a configuration. Right, Dan? I would think, huh?
Yep. And
If
any
I had a-
subset of an MDD can be in a configuration.
Yeah. And
The limitations with the part station and tool group are if you have no matter what configuration is active, you always have to have a part station 1 and you always have to have a tool group 1.
Yeah.
You can skip other ones if you want. So you can have a removable subspindle, for example. That's just fine. But you can't have a removable main spindle. You always have to have part station 1 defined.
Yes, always. At least one, yeah. And it will actually chirp back at you. I believe it does chirp back and say, hey, you need a part station for this. It will come back to that. So this is this setup here, very simple, nothing too crazy. And it works out really well. So this is brand new. Now this can get really complicated. Let me just bring up another, let's do this. This one's kind of cool. And again, I was trying to think a little bit outside the box on what I can do, what might be useful for people. And at the end of this, you can have all these configurations. So you have the samples. I'll give you all this stuff. I just got to package them up. Now, here's one here that's pretty interesting. So here's a part here, and it's on a horizontal machine, and this is, again, pretty normal. And what's interesting about this now is I actually have 3 different types of configurations for this machine. I have one with a rotary table, one with an angle plate, and just a blank table. So 3 different ones. And I did run into a small issue, but I'll discuss that with Daniel offline. We won't talk about that in this class, although I'm sure you guys are going to run into it and going to ask those questions. But what's cool about this is each one of these has its own part station and its own part station location. So for the blank table, the part station is right on the table. For the angle plate, I put it like right here, and then for the rotary, naturally, it's on top. So it's actually pretty cool. I mean, okay. And if I wanted to change it to rotary table, again, this is not, well, I guess we could use this part on the rotary table. It's a rotary table. And again, the parts need to be, you know, where they actually work to the rotary, you know, to the different configuration that you have. I mean, we can certainly move the part around and do some different things, but this part is built basically for the angle plate. So my suggestion would be that if you have, or you do build a machine for your customer that has multiple configurations, I would suggest that you start with the configuration that is going to work for you, right? Don't start with a rotary table and, oh, I want to do angle plate, because you're going to be all screwed up, okay? But I just wanted to show you that you can change the configurations on the fly, and all the things change, right? Everything changes. Which is
So you
cool.
say this works for milling and turning, or not?
Yes.
It's like turning, switching from collet chucks to 3-jaw chucks.
Yes, you could probably do that. I haven't done that. I was going to show you one here for turning, so if you give me a second. You're way ahead of me. What I set it up was, and let's just look at that, and then Andy's going to talk about the Swiss, show us a Swiss example. And I have one here for trunnion, but basically they set up the same way. This one here is a little bit, it's a little bit more trickier. Okay. Let's just pick this part here. And I just set this up on a machine just because I'd run into multiple problems with talking to different people about, again, I'm going to talk about this a little bit later, but talking about these 15-degree rotary blocks. Okay, so the block that you have a machine that has 24 positions, and you have these blocks that are at 15 degrees. And I get all kind of weird, you know, comments. Oh, you can't do that. You can't do this. Well, let me assure you that it works. If you set it up properly and you make it work, it will work properly. There's no question about it. And I was told that we can't do this on a 2-axis lathe, and that is a lie. I'll show you multiple examples that I set up already. The problem is, typically when you set up these weird 15-degree blocks, not to get off on a rant, but they're not set up properly, or they're off center. And that's what I found. 90% of the cases, they're off center, and that's why you get all the errors. But that's not what I want to talk about here. So we'll talk about that at the end. All right, so in this case here, this is a machine that has many things, okay? And I haven't done the chucks. I suppose we could do different chucks. I don't see why you couldn't build a configuration with different types of chucks. I've done it with the turrets. Okay, so in this case, this machine, and this actually is a Haas T20. It's a 2-axis lathe. But believe it or not, in their configurations, these are the configurations that they can have. They can have all these different configurations. Okay, so they can have 24 positions, non-milling, milling. It's very strange. They can also have a sub-spindle and a tailstock. So the question was, can we do this? This is real life here. Okay, especially for you guys who are out there doing demos and stuff. This is real life. I have a customer now who has, you know, this VDI turret, or I have a 12-position or 24-position turret. Okay, so the answer is it can be done. Yes, it's all about putting in the work and making it go. Okay, so in this case, if we look at this machine, so here we are, 12-position turret with the tailstock. See that? And it all works just fine. Now, if I wanted to say, in this case, for whatever reason, I'm going to say, oh, gee whiz, this has a sub-spindle. Now everything's going to change. Okay? Now everything's changed. Not only do we now have a sub-spindle, and it doesn't find the right value, so you're going to have to be kind of careful with that. You have to go in and make some adjustments here, which I'm going to do really quick, just to show you. But the idea is that it does work. Go ahead.
Yeah, initial start unchecked on the sub spindle.
Oh, is that what the problem is? Sorry.
Yep. Not a
Well,
problem.
that's why I have you on the line. But anyway, now we're going to look at the same machine, only now it has a sub spindle. So you can do all these really cool configuration things. It takes a little bit of work, but it is doable. Okay. And again, it just depends. I will warn you, however, in my opinion, and this is only my opinion, whenever you start something, make sure you're using the configuration that you want to use. Because some of these things aren't going to work on a 24 milling spindle, or I should say it shouldn't go backwards. If you have a turret that has milling capabilities and you go to a turret that doesn't, they're going to be all X'd out because it doesn't apply. Okay. So with that
I'll
said,
also add here that just because you can do something with configurations doesn't mean that's necessarily how you should do it. Configurations is very powerful. Basically, it gives you the ability to make small changes to the MDD at will. But there are better ways to do some of these things, or there should be better ways to do some of these things. So, for example, when you're changing a collet chuck to a 3-jaw or 6-jaw chuck, you're probably better off using intermediate tooling fixturing for that. It's actually designed to do that. Whereas with configurations, basically you are putting too much information in the MDD, and that's going to come back and bite you later. Similarly, with yes, you can set up one MDD that represents the entire range of ST20s, but nobody has bought all of them in their shop, and so for no customer is this MDD actually the right choice. It might be the right choice to demo. If you're going out to the Haas open house to demo, this might be a great way to have this set up. But just keep in mind that just because you can have all the configurations that somebody could have bought, that doesn't mean that that's the right solution for that person.
no, I agree, but you also have to understand that this is for demo purposes, and this is to show the power of what you can actually, if you really needed to do this. I don't disagree with what Daniel said. But the idea here behind this particular setup is to show you guys, and it's also for learning, that you can go in to show you the different ways you can set up configurations. Don't take this as a criticism of the demo at all, because it can do a lot, and it's important to see what it can do, because that might be useful for you. If you are doing a lot of open house demos and you don't know what machine's going to be on the floor, this might be exactly what you need. Exactly.
And we're not going to stop you from doing that. I would just encourage you to think about it as you're setting these things up. Is this really the right solution?
Right.
It might be. It might not be.
I don't disagree with you. This is just to show that, hey, listen, we can pile a bunch of stuff in there if you really need to do that. I wouldn't either. I agree with you, Daniel. I would set up one turret and a sub spindle, because I'm not sure that they would take it on and off. But for people like us who are doing demos, you might want to set something up like this. I don't know. Anyway, this was just an example of how it all sets up. And again, not that big of a deal. You just have to put in the work to set everything up. We have multiple turrets in here. You have the 24 station turrets. So you could physically have, this type of setup as well. So it's pretty complicated, but once you do once or two, it's not that big of a deal. Set up what you want, put the stuff inside of it, different pieces that you want, and you're good to go. Okay?
Steve, one quick question on this. Let's say that we have one master Haas that has every flipping option available built into the machine manager. How does this behave if we start to delete items out of it?
Oh, they just go away. It doesn't really affect anything.
Just fine.
Yeah,
so
it just goes away.
A way to use this, guys, might be to build your master have it done once, and then when you have a customer pick a particular style of machine out of that family, delete everything else out of it and hand them that.
Yeah,
Absolutely.
That way we're doing the work one time and we're just cleaning it up in order to present to the customer.
Yeah, and I mean, and the idea behind this was just to show you that, hey, this particular machine actually has these style turrets on it. This is not just something that I made up. If you go on their website, they offer this many different configurations on that machine. And that was what I thought. That was my thought process was, in a demo environment, you may want something like this, whether it's Haas or Okuma or Doosan, or it doesn't really matter to me. I could care less. But you could put multiple things together in a demo. But I agree with Daniel. If you're doing this for a customer, yeah, I probably would set up 15 different ones. On the milling side, it's different though. On the milling side, I would not agree with him. I would say I do want something that has an A-axis trunnion and something that's blank or has an A-axis. So you could have two different rotary tables. Actually, you could have 3 different rotary tables and just a blank axis. And I've seen that before. Guys have bolted stuff on and off. In that case,
This definitely
is. It's good. For turning, not so much.
It is intended to be a customer-facing feature. And just think about what you're exposing to your customer. That's all. If the customer actually does set his machine up differently on different days, that's absolutely a case where you would want to use this.
Yes, and it's very cool. And it's really not that hard to set up. You set it like you see here, right? Give me a group, give me a configuration, give me a group, put the pieces in there that you need, save, it's done. It's really not that difficult.
I think this would be also helpful for Swiss type machines.
Yeah, that's
which have different linear solutions.
Yes, wait, that's next.
Absolutely.
That's next.
Yeah, I think
Nice,
Andy will be
nice.
talking about that. But that was one of the motivations for this is the way that Swiss machines use tool blocks and use the control to interface with the tool blocks and change the number of tool positions on the machine, for instance.
Correct.
Is something that is very important to get right and can only be gotten right in the MDD level. You can't do that with intermediate tooling.
So let's with that said, I'm going to stop sharing my screen, and Andy, why don't you come out and show us this configuration stuff on the Swiss.
Okay, here we are. It's a Swiss machine. It's sort of like a Citizen L-type machine. There's similar other machine brands out there that look almost the same. And what we're going to do here, we'll talk about configurations, as Steve started with his examples, great examples. Here, basically, it's like the main spindle or guide push here, tool group number 1, tool group number 2, tool group number 3, and 4 and 5. And we're going to switch around things a little bit. So those are the 2 tool blocks I want to talk with you right now. And I'm going to go right into the document control and configurations. The way I have set it up, our configurations, we have a B-axis, that's this guy down here. B-axis, see that, swings around. And then we have a thread roller. We're gonna look at the other part with the thread roller in it. I'm not switching to that right now. Then we have tool position 8, which is this guy. Then we have tool position number 9. And then we have tool position 8 and 9, both of them. That's what we see right now. Or we have no tools. Okay, so if you just want to switch and see, hey, I need all this. I don't need this station number 8. It's just okay, like I want to change to position number 9, and it's going to take my position 8 away. And there it is. 8 is gone, 9 is there. And if you watched and looked, okay, with when we had them both, okay, the tools were actually like in 8 and 9 a little spread out. Okay, so I just can go back and forth. 8, I can switch back to that. Let me switch now to 8, and then once we do and switch them all off, this is number 8 now. say no tools because at some point maybe I don't want to use any of those. I want to use tool number 2, those guys up here with that little basic tool pointing down. So no tools. I'm going to take 8 and 9 off, and what's going to happen is it's giving me an alarm. And rightly so. Those were the operations, and those were the tools. Let's see, let me go this down a little bit. Those 3 tools, they were in position 8 and 9, okay? But I took those positions away with no tools, so those tools are not valid anymore. And the system alerts me of that and says, hey, I don't know where to put those tools. Fix it. Okay. And just to see it run real quick, actually, let me go back to maybe this station. And here we get our tools back. They're valid again. Our operations are valid again. And we just run it real quick. See that? And then we switch to another part. Typical Swiss turning. Drilling. And we do a little bit B-axis. Drilling over, B-axis drilling over there. Okay, so while we are on it, let's open up my machine manager real quick, just to show you similar what Steve had with his machines, to see it in machine manager. Let me talk about the configurations. And here are my configurations. It is, we are talking about tool group or configuration group number 1, and here you see it actually there was the no tools that I mentioned when we got the cross out tool positions, and then we have tool configuration position 8 and 9, position 8, position 9, and then we have only 9 and only 8. Okay, so those how I set it up. Those are the individual configurations. I named them. The naming convention actually is pretty straightforward. Again, it's tool group number 3, so TL3, T3 again, until T3 again. So we can do it multiple times and just name them a little bit different so you have a little bit of an indication which ones are you using. Okay. Any questions to anything of that before I go to my thread roller part?
Yeah, so when you use these blocks,
yes,
you have to have, you can't use the same block over and over again, right? Don't you have to have different blocks?
You have to have different blocks. Basically, you have to have a block in your machine simulation thing and machine manager for position number 8 and position number 9. If you have a position number 7, you would need to block in position number 7 as well.
Oh, that's not what I mean. You have both blocks and then you have one each. Are you reusing the same block? Does that make sense, what I just said?
In the same position, yeah, it's the same solid.
It's the same solid?
Yeah, he's just added that solid in multiple places in the tree, which
That's
is
exactly. It's
totally
the same
valid.
block. In this particular case, yes, it is. It could be different. There are different blocks out there. Maybe just with, yeah, go ahead.
I just wanted to be clear that, make sure everybody's clear that, do you need, like this block here, for example, the one on the, that would be 8 maybe. Do you need 2 block 8s to go into 2 different configurations, or you can use block 8 for 10 configurations? Or do you need a new solid for each one?
No, you can reuse them.
Okay. I just want everybody to be clear on that. That's all.
Okay. Sorry, I didn't, by the way, get what you were.
That's all right. That's all right. I think it's important because I know that a lot of the guys that do this stuff are going to jump in here now and they're going to do some crazy stuff. So I just want to be sure that everybody's covered on, you know, what we can do and what we can't do. That's all.
Okay. No, that's good.
Thank you.
Not a problem. Okay. Any more questions? before I go to another part, and it's actually the, if there's no other questions, we're gonna go to our thread whirler part. It's the same, it's the same machine or the same configuration, the same MDD, but yep. So in this case, we do with some thread whirling, same machine, same MDD configurations. Okay, so here I said, okay, I switched from B-axis to the thread whirler. That's the thread whirling head, and with no tools. Okay, so no tool blocks, no 8 and 9 in the front of the part. Okay, if we go and switch on machine sim, we see it right away. Zoom, and here we are. So I pretty much can. So as you see, there's no toolbox number 8, no toolbox number 9, but I'm using those tools, which actually are tool group number 2, actually. Okay, so when I run it real quick, of course it's a thread whirling part, and here, of course, this is always a little bit pain in the butt that we can see of a part being thread whirled. And what I have done, just for fun, I have done something, a little bit, some extra work with that thread whirler. I opened it up, I cut out some sections of the thread whirler, and I'm using that now actually more as like a visual benefit, not really as a, but I included that into my configuration in the MDD. Come on. Okay, here is the cutout of the thread whirler. Same part, same thing, everything, but I just have the benefit now that I can see inside of our thread whirler and can follow it through. So this is actually, again, something like that you normally maybe not wouldn't do, or just say, okay, when we said, okay, the configuration is multiple configurations. This is again something for demo, or just, you know, some more visual of the part. Okay, and that the configurations allows me now to do that. And I took advantage of this. Okay. This is actually pretty much what I have on this one. I hope it was pretty, or actually made it pretty clear. If you want, we can have a look into the machine manager as well as that. Okay, so here is my configuration group number 2, which is tool group number 4 and 5, which would be the B-axis down here. Position or tool 5, okay, tool group 5 actually, if that is actually working for the sub spindle. Tool group 4 would be the tools for the main spindle. But here we are talking about a thread whirler. So this is a thread whirler, and this is my regular one, T4 and 15. That's the normal one, the solid one, and then I just created another configuration with the whirler cutaway again. Just using the advantage of the configurations to have that added just for visual, how do you say it? Visibility of the cutting insert. Okay. Questions to that? I hear no questions.
Are these samples going to be available to us?
Yes.
They will, exactly.
Well, yeah, we will make them all available. That was the idea of putting together a couple of different ones, even though you may not, you may not need them, but at least that gives you some ideas of, what you can do, and you can go back and look at them and stuff. So yeah.
So yeah, exactly. So I went through it, okay, to make the inch versions and the metric versions for our friends in Europe, or China, or other metric countries that they are in this world. Okay, so basically for us guys here in the US, okay, we have inch parts. And the rest of the world, okay, with metrics, I have them available in metric as well. Okay, with all that, this is pretty much my contribution on the Swiss side for configurations. And I'm gonna move it. I think the next one is Dan, correct, Steve?
Yep. So the next thing is there's no more questions about the configuration stuff. We're going to move on to the 5-axis. There's a lot of new functionalities in 5-axis. So Dan, are you out there?
I'm here.
All right. So if Andy would turn off your screen. Dan?
I'm here. I'm getting my. All right. Can everybody see that?
Dan? All right.
Is this?
All right, Dan, it's all you, buddy. We're going to turn this over to Dan. We're going to do all 5-axis improvements. So ask some questions, and we'll go from there. All right, Dan, all you, buddy.
Okay. Everybody can see my screen? Can hear me?
Yep.
Yes.
Yep.
Okay. All right. So new toolpath added in 2022. Rotary in 5-axis. This is specifically for parts that are shaped like this, screw type parts. Okay, and that's all that it will work on. It can be a closed pocket as long as the bottom of the pocket is radial. It can't be flat. Because the way this thing works is that it looks for the smallest diameter on your part, and then works out from that. Okay, and the reason for me that this was so important to get you guys this is that the roughing portion of it allows you to move the tool off center, which is something that we can't do in any other module that we offer. So this is what I hear a lot of people wanting to do, and prior to that, we really didn't have a good way to do this. So now we can move the tool up to 50% of the diameter of the tool. Okay, so there's roughing and finishing here. This radius constant is the only choice for now. There will probably be more options added as this toolpath progresses. For roughing, you can do a straight offset, or you can do offset and spiral. And the spiral will just keep a constant load on the tool. So you have those two choices. Sorting kind of works the same way. How do you want to cut, one way, or do you want to zigzag? If it's going the wrong way, use direction 1. It's not going the way you want, then switch to direction 2. And then some options down here for how to process depth, steps, and step over. And what I've seen with this toolpath so far, I prefer this. There's a constant depth step and an adaptive. And the adaptive basically means that it will hit as many levels as there are on the part. So if I tell it to step down, and I'm in inches here, but either way, if I tell it to step down 1 inch, but it sees an intermediate step between that, as long as there's more than 1% of the distance that I've given it, it will add the pass to cut that as well. And that seems to work the best. And setting this up really could not be any easier. You select the whole part. You tell it which axis the part is rotating around. So and this again, this is determined by the coordinate system that you've chosen. So we've chosen the XY plane here, and that's the XY plane. So our axis of rotation is X. Tell it how much stock you want to leave, some cut tolerance stuff. Again, the linking is kind of condensed to what is relevant to this type of toolpath, but the choices are pretty much the same as in any other toolpath. Your clearance distances here, and how do you want to ramp? If you have to ramp, if it can find an open spot off of either end of the part, then it will do that so that it won't plunge into material. And then clearances for the tool and the front part of the holder. Any questions on what I've showed so far?
Is this available in standard 5-axis, or is this chargeable?
It's bundled into 5-axis.
Okay.
It's standard with 5-axis.
Yes.
And will our competitors also have this? Because the impression I got then is this sounded like it's unique to Gibbs, but not.
It is.
Some
not.
Of them do, some of them don't.
All
Yeah.
right. Thank you.
I think Mastercam is bundling it with their standard 5-axis. I don't think EdgeCam is. I'm not quite sure what anybody else is doing.
All right. So,
but this is not like Geodesic, for instance, which is really, we're the only ones that offer it at that price point.
good point. All right. So, as you can see, we're staying off center. I put in 190,000, so we're there. There's this wiggle here is because of the sim. Not you shouldn't see this in the toolpath that gets posted. And I'm not going to let this whole thing run, but you guys get the idea. See, even there, you can see that it's starting outside of the material whenever it can. But it will switch from one side to the other when it reverses direction. And that's really slick. And you have to understand that the math to be able to do that is extremely complicated. So this is something that I think you guys can market to new customers, but it's also something that'll fill a gap that we currently had with the other modules that we offered. And there's a finishing routine in here as well, but understand that it's always on center. You can't shift it. You can see that your choices are greatly reduced here. It sets up the same way as the roughing ops. And as you can see here, it's only finishing the faces of the flights, right? So it's not set up at this point to add those passes in between. But here's what I'll say about that. A part like this, we have never had a problem with finishing a part like this. The problem has always been, how do we get all that material off of it in an efficient way? So my recommendation to you guys would be, use the roughing to get that material out of the way, and then go use a different toolpath to finish the thing, whether it's a swarf cut or a parallel to curve, something like that, to finish this thing. Because again, finishing was never a difficult thing to do for a part like this. It was always, we can't rough the material off and not destroy the cutter, because prior to this, we always had to stay on center. Any questions?
What tool types do you support?
Anything that 5-axis can support.
Okay, so it could be a conic with a ball on them.
Yes. Yep.
Okay, thanks.
Yep. And understand that for roughing, you're gonna want to use a straight flute end mill, maybe with a corner radius, and that's what I've set up here, just because that's going to be more efficient. But it'll support any tool that 5-axis can support. It will support, except for a form tool.
Yeah, I tried this, Dan, and it works really well. I tried this particular part.
Yeah.
But I have a question. Like, I'm assuming, I didn't try it on a different one. Will it work just as well on a variable pitch?
Yes.
Okay.
Yes. Yes.
And what about multiple diameters with that variable pitch?
If you have a part that an example, I don't, but it should handle that as well.
Okay, I'll have to try it.
Yeah.
It is designed to. The roughing stuff is very good.
Yeah.
And it will also handle conical parts.
So I'm sorry I skipped that, and because I really couldn't find a good part or example to do this, but it's fixed. Okay, so you would have to define the angle, and it would have to be a fixed conical angle on the part. But it can also do this, obviously, on conical screw type parts. So what's going to happen is when you define this angle, it's going to the software is going to look for that minor diameter relative to that angle. So it's going to basically any diameter below that, it's going to find the smallest diameter and then work up from that.
Very, very cool, because that was kind of a pain in the butt before.
Yeah, and I listen. I lost a lot of hair trying to find another way to get the tool off center to rough a part like this, and obviously there wasn't a good way. There wasn't a good combination, or this toolpath wouldn't be offered now. So they wouldn't write new toolpath if you could do this with some of the older stuff. Questions? I would like some feedback from you guys on how much this gets used. I'm very because I pushed really hard to get this added to our package this year. That's it. No more questions? All right. Well, we'll move on. So new for this version is a operation modifier that allows you to convert 5-axis toolpath to polar.
Yay.
Okay, but you need to understand that all of the rules for polar machining apply here as well. Okay, so it has to be a 3-axis toolpath created in the 5-axis module, but it has to be a 3-axis toolpath, and the tool has to be parallel with the rotary axis. All right, so if you imagine like a lathe with live tooling and a C-axis, the tool always has to be pointing towards that rotary axis. So this will work on lathes and mills, but more times than not, this is used on a lathe that doesn't have a y-axis. So it's straightforward to set up. I just set up a quick deburring op, and basically, well, actually, I set up 2, but so these are just copies of those operations. Just right-click, add that, click do it, and you're good to go. And let me just do that. All right. And you can't see it because it's on my other monitor, but clearly, you know, this machine doesn't have a y-axis. It's trying to move in y, so that's why it looks like that. Drag this up here. All right. And now we're polar milling. Again, all the rules still apply to this, okay? So, number 1, the part has to be, the 0 of the part has to be the same as the axis of rotation, okay? So, if you do this on a mill, if you want to use this on a 5-axis mill, well, that's not going to be. In your part offset, on the DCD in your part offset, X and Y will have to be 0. If you shift any at all, this won't work. That toolpath will blow up. Any questions? Man, are you guys all asleep?
So
Well,
Dan,
the good part about this, we don't have to remember to copy that DLL every time we have a new.
Oh yeah, right. Yeah. So in prior to this version, there was a plugin that I guess I was the main person distributing it, but a couple other people had it as well. And the bad thing about that plugin, it did exactly what this does, but you had no way of knowing that if that operation had been converted or not, because it didn't put anything on the operation tile. So you had no way of knowing.
Redos.
Right. Yes. Thank you. Yes. Yeah. Because it's the not modifier. If you redo, because that happens after the toolpath is initially created. Any other questions? Oh, all right. Let's move on. All right, new in 5-axis, again, new for this year, is your default lead in and lead out now at the bottom of the list has an automatic arc selection now. This is nice because before you might have to try tangent arc, but that's going the wrong way. So now you need to do a reverse tangent arc. And it wasn't really intuitive to kind of know which way the arc was going to go. It depended on the initial orientation of the tool and the normals on the first surface that it was going to contact. So now automatic arc, and basically you can tell it, remain tangent to the surface, the initial contact point of the surface. You can tell the tool to stay fixed, which means don't change the tool orientation, or you can tell it to tilt, and then you can do automatic, which it'll just pick out the best option. But the nice thing about this automatic arc is it will pick out the proper direction for the arc lead in. So all you have to do is give it a min and a max on the radius, and it'll handle everything else for you, including if there are any adjacent surfaces that the tool might collide with. This will look for them and trim the tool path or redirect the arc so that you won't gouge into any of those surfaces. And this is basically what it looks like. Oops, sorry. It's a really, really, really nice thing, again, because a lot of times, especially in the middle of a tool path, if the tool has to retract to reposition somewhere else, and you want it to lead in and lead out, again, the direction of that arc lead in could possibly be different than what you've chosen for the initial lead in and lead out, and so then it wouldn't work. So this would be my go-to all the time, unless you're doing a specific thing that requires a specific type of lead in. This would be my go-to every time. Questions? Oh, you guys are easy. All right. Okay, so if you have attended one of my 5-axis classes in the past, I've offered an approach where you create some additional surfaces and let those be considered the part, and then on the actual part you want to cut on those surfaces, make those check surfaces instead of part surfaces, and have that tool path, the tilt of the tool be controlled by the other surfaces, so that you don't get well, there's a bunch of reasons for that, and so what is new here this year is I got 2 operations set up here. They're both morphed between 2 curves, and for this first operation, I just told it, keep the tool normal to the vectors on the part. And when we run this, you'll see that there's a lot of back and forth. And it's not necessary. So in the past, what I would tell you to do is create another model or another set of surfaces and make the part the check surfaces to try to reduce some of that back and forth tilting. So for this year in tool axis control, again, It's the last option at the bottom. Tilted with fixed angle to surface normal, and that means a reference surface. So at this point, the green that you see here is my reference surface. So the toolpath will initially be calculated on the part, but it will follow the closest point on the reference surface. It will follow that normal. Okay, so we're saying we want to cut this part, but we want the tool to tilt based on this reference surface, this secondary surface. So you get, basically you get the same result as what I was showing you guys, but it's built into the tool axis control now. So now you're not wasting a gouge check strategy on doing this. It's built into the tool axis control. So that makes it, again, flow a little bit better in the
Also
creation.
a lot faster to calculate.
Yes, right,
Because
yes.
it's just pulling normals from that, not trying to collision check it.
Yes, exactly. So that's what's happening. So you can see now, drastically reduced all of the back and forth tilting. And again, the contact point on the part, wherever the tool is contacting that, it will look for the closest point on your reference surface. And whatever the normal is right there, that's what it will align the tool with. So even though, you know, our part is above our reference surface, it's still going to look for the closest point to get the normal, the vector of the normal, so that you know, to control the tilt of the tool. So before it was kind of a cheat, kind of, and now it's built into the tool axis control. Any questions on that? Really? Okay, so in previous versions, for a new option in tool axis control was that you could define a contact point. But the problem was this only worked for rounded end tools. So if you were using a square end mill, you didn't have this option. So basically what's happening is, you know, it's wanting to know where, give me a point on that tool. And these are percentages. These values are between 0 and 1. Or this box is anyway, this lead angle, no. But your value here is between 0 and 1, and what it's asking for is a percentage of the flute length that you've described the tool with. So again, 0 to 1. So that is 5%. It's a little tricky. Okay, and that's on a ball end mill. So we'll you know, oh, I didn't have. Okay, well anyway, we'll get back to that. All right, so new for this year is that option now applies to all cylindrical tools. So here we just have a square end mill, and so now I can define a contact point or a height on the tool that I want it to maintain contact with. And it's kind of hard to think about when this might be useful, but even if you just look at look at this little demonstration here. All right, we want to maintain a certain point of contact on the tool, but what's going to happen is the orientation of the angle of the tool to the part would have to change in order to maintain that contact point on the end mill. And prior to this, you didn't have a way to do that. If you defined an angle, then anywhere on the tool, on the flute of the tool, as long as it was making contact with the drive surface at that angle that you described, then that was all you could control it, or the only way you could control it. So now being able to define a point on any cylindrical tool, just some new added functionality there. I'm curious again to see how much this gets used in the field. Any questions? Again, I'm going to say it one more time. This value is between 0 and 1. So that is 25%. And I can click the 2 here and give it an ending. So I could tell it start at 25% up from the bottom of the tool and end at, 10%. And it would constantly adjust through the toolpath to achieve that. No questions? Any questions? I don't hear anybody snoring, so. All right, let's see. All right, we got 2 more.
Dan.
Yes.
Can that be changed? Well, I see some comments there in the chat box. But can those boxes be changed to percent?
I wish I have sent in a similar request, not for those, but there's another place in that module that it's they're asking for %, but they're at the same time asking for a number between 0 and 1. And then there are other places where percentage really does mean percentage, so it's 0 to 100. Yeah, I'll send it in again and see if we can get somebody to do something. But it shouldn't be that difficult to do that. There obviously there are going to be differences between what was written 5 years ago to what was written now, but I mean you guys know, depending on the toolpath, it can either ask for climb. There's one where you can conventional climb, clockwise and counterclockwise. Mm-hmm. There's 4 choices for direction. And the newer stuff just has direction 1, direction 2, which is perfect because now it's not confusing.
Yep.
Some continuity within the module would be nice. Yep. I will make that request again.
Okay.
So this is a pretty straightforward one. In geodesic, there's a when you define a guide curve, now in the advanced window, propagation direction lets you choose left, right, or both. All right, and so here we've chosen both. But if we choose left, what you'll see is we only get toolpath, basically should be inside this window. All of these are examples of that. Yeah, so we get toolpath inside that. And that's it. I have a lot of examples here of basically the same part, but choosing sides. But as far as the new feature goes, that's it. So propagation direction now lets you choose a side or use both sides. So anytime you're using a guide curve, you can choose left or right if you want. And that's nice if you wanted to actually skip a section. So if I wanted to machine this part but not machine this area here, then I would just choose the right side of the line, and it would skip all of this here. Any questions? All right, well, we're almost done. The deburring toolpath has some expanded functionality this year, and so it still works on the same principle. You have to select the faces that make up the edge that you want to deburr, and it has to be an edge. But now you can, with either constant width is what you're going to want to use for this feature. But constant width, you give it a value, and now I can tell it take extra passes. So instead of taking one pass on that surface, you can call out how many you want. So here we've called out 8, and the width of it's 80 thousandths. So essentially, this would be 10 thousandths step over passes, 8 passes. So you don't have to modify the model if you want to put a bigger chamfer than what is there. And the really cool thing about this is you can also round over an edge. And just understand that this, when you choose rounded, this doesn't mean an 80 thousandths round over. Basically what it means, or 80 thousandths radius. Because you've chosen constant width, it's going to try to maintain that 80 thousandths width of the radius. So from where the radius starts on the one face to where it ends on the other face should be approximately 80 thousandths. And again, you
chord length rather
yes,
than radius.
right, yes, thank you. All right, and just so Limitations for now are it won't zigzag. You can only go in one direction. So it's going to have to kind of loop. So make a pass, go back, same place, make another pass. Right now it can't zigzag. I'm not sure if they're working on that or not. But again, the beauty of it is you just rounded over an edge on a part without modifying the model. Or you added an 80 thousandths wide chamfer without having to modify the model or make a new model.
Could you use it the same thing with the modifier that you showed us earlier?
Yes, yes. I can't in this, because this is, but yes, yeah. Again, as long as it's a 3-axis toolpath, and this is because we've in tool-axis control, it's locked down to 3-axis. So as long as it's a 3-axis toolpath, and the
partisan center.
Yes, yes, yes.
Okay. Thanks.
Yeah, anything, yeah, that's a good question. Anything in 5-axis, any toolpath in 5-axis now can be converted to polar, but it still follows the polar rules for every other toolpath.
Okay, thanks.
And I'm pretty sure that's all I got. So
I've got a question. This
okay.
This is Don Casanova.
Hey.
So in using the deburring process, how does it determine? This is a little off of what you were doing, but how does it determine where on that ball it's going to contact?
I cannot tell you.
Because I know we've done some internal deburring, and it seems to struggle a lot with, I have anyways, trying to get it to contact in a spot where, it's actually usable.
Yep.
But it's a great toolpath, don't get me wrong. I love this toolpath.
Oh yeah, me too. Me too. So I don't, it does it automatically, and there's no way to change it. There's no option for defining a contact point. But I would imagine, okay, so if this is just one pass and we wanted the width to be, small, right? We're going to make one pass, and we want that width. We've defined the width. Then what I would imagine is, again, depending on how it can tilt the tool, but let's say it can't tilt the tool, right? So say it is a 3-axis part or whatnot, then there's only going to be one chord on that ball that will give you that width and remove the same amount of material from both surfaces.
Right. If there was an option, a way to determine, to be able to set where that, it would have to be in a 5-axis or a 4-axis.
Sure.
Situation. But if we could get something where you could tell it, where that contact point is, or at least close to it, I think that would really be nice.
I agree, and I will send that in as a request. I agree. It really would be nice. But again, it would be limited. So again, this is how I imagine it happening, is that when you tell it, when you pick those two faces, it's going to try to remove an equal amount of material from both faces. And so
sorry.
So again, if you're locked in a 3-axis toolpath, then there's only one spot on that tool that it will be able to do that. But yeah, if you could make it, don't worry about how much you remove from one face versus another, and you just wanted to break the edge no matter what, then you could define a point on the ball to do that. I'll send that in as a request.
Yeah, the reason, just being able to tilt the tool would be nice, if you could just give it, a 5-degree tilt sometimes, because
Right.
there's been places where I shank out.
Sure.
And the only way I could do it is either, create a tool with, a 10 thou shank and a 50 or 60 thou ball, which is unreasonable.
Right. Yep.
But if I could tilt the tool, or I could tell it, hey, I want to be 20 thou off center, up above center, below center.
I'll send that in, and it may be something they're already working on.
Appreciate it. Thanks.
Yep. No worries. Anybody else? Questions? Any questions?
Yeah, what's for lunch?
I got crackers.
There you go.
Yeah. That's all I got.
Okay, well, thanks, Dan.
My pleasure.
All right, we have
right.
a couple, if you could just give me the screen back.
Yeah.
We have a couple more things we want to talk about. One completely unrelated to this version, but we're going to talk about it anyway. So, let's see. Oh, wrong screen. Sorry. Give me a second. Okay, can everybody see my screen? I hope. So I'm going to talk a little bit about this 15-degree offset tool issue that I've been running into, and then Daniel's going to go back over the work fixture offset stuff. And I want to put this to bed once and for all. So lately I've been getting a lot of questions about, oh, it doesn't work, this and that, how do you set it up? Well, the reality is this. When you have a turret like this, for example, that has 24 positions, the blocks are designed specifically for that turret. That's it. There's no other, you can't exchange the blocks. It just doesn't work. Even though you think you can, you can't. What we do is we take everything from the center of the turret, okay? So you can see that I've drawn a couple of lines here, and in this case, this is a BT65 turret, which is becoming popular. And this block designed specifically for this turret, and it works. It's flawless, okay? It does work, 100%. And I'm going to show you something in the intermediate tooling on make sure that you know how this all works. But the point is this, and I've heard this 100 times. Oh, gee whiz, I have this block and it doesn't work on the turret. Well, here's one of the reasons why. Well, here's a different turret that has 24 positions. So if I move this into the position that you think it's supposed to be, it can't line up. Because even though it's still at 15 degrees, the position is completely different. The distance from the center is different. So this hole actually needs to be moved over here. So for this particular turret, you need a different block. That's it. There's no other question about it. That's it. Okay? So the block needs to match the turret, and I have asked some experts who have these types of machines with this type of thing, and that's exactly what I was told, that these blocks need to match. That's it. Okay? So if the block doesn't match, you need to move the hole so that it lines up where you want it, or get a different block. It's that simple. Okay? There's no arguing about this. It's just how it is. Okay? So you can tell I'm pretty adamant about that. Answered this question a lot and done some research, and that is the reality. Now we get into this type of block, and this is more common than not. Now, I was told by some individuals that we can't do these types of blocks on a 2-axis lathe, and that is a lie. It's an outright lie. And the reason is that it doesn't work is because these things are off center. And that's the only reason it could be. There's no other reason. I've spent hours and hours and hours checking on some of these blocks and what some of these things do. And the reality is, when you look at some of this stuff, this is position 1, for example. This may be off center a little bit. And it just doesn't work, especially for 2-axis. Now, if you have a Y-axis machine, that's okay, right? It works. And sorry for the noise, but they're pouring concrete across the street. And if you hear that noise, there's nothing I can do about it. Okay? Now, on the 15 degree, what I also found is that although you might set the position, it may not be right. And you're going to get an error message. Okay, and I'm going to show you this here in a second. What I want to talk a little bit about, though, is this. Let's see, I think this was in this library here. Sorry. I'm trying to remember which library this came out of. Okay, it came out of this one here. All right, so the way this sets up always, you have the 0 position here, okay, which is what is, it has to be exactly in line. And I would take the time and be very specific on how you set this up to make sure this is exactly at 0, okay? That's this position here, right? It's exactly at 0 and Y. And the 15 degrees is a little bit different. What we'd like this to do is to just automatically drop into position. And the way you do that is this right here, when you set this coordinate system up, even though I set it up as 15 degrees, but when you actually put it in there, and you can't really see it, you see I have P2, so it's the second position, period, which tells the software, hey, this is the second position you want, and then a space, and then whatever name you want to give it. This is how it works. There's no other way, okay? So it's always P2 or P3, depending on the position, period, a space, and then whatever the name is. I find this to work every single time. The bigger problem that I see, and not just that, you may not have known that that's how this thing sets up. The biggest thing I find is that these are off center. And it all the time, it's off center. So let's go ahead and just look at a quick part. And then we'll pass this on to Daniel, and then we'll be done. I just want to get this out because it tends to drive me crazy that we're getting into more and more of these, and it'd be nice to just, okay, let's just put this to bed, make sure everybody knows how this works, and that's the whole idea here.
Steve, if I can interject, the period was and the space was the missing equation that nobody seemed to know.
Yes, I agree with you, and that's why I'm going over it again, Dave. That's the piece that even I forgot about, because I went back and looked at a bunch of the stuff that I did before, and sure enough, it was missing. And that's why I'm trying to reconvey that to everybody. That's really what we need. I'm going to put together a small document just because, I mean, it's this kind of form is perfect for this kind of stuff, right? We can talk about it, we can get it out in the open, and make sure that everybody understands what's really going on here. So first of all, one of the things that you're going to find, let's see if I have it in here. Let's put this in here. Okay. One of the things that I found that really drive me kind of crazy, this one goes right in the right spot, and that's what I would expect to have happen, right? It goes into that 0 position. That's exactly what I would expect. Okay. Now, what we have to do is make sure that the software knows where that goes. So in the machine data for this configuration, I have to come up here and say, oh, it's only got 12, sorry. Got the wrong, well, actually, let's do this one here. It doesn't really matter. I just want to be able to show it. So we got 24 positions. I want to say block 24 or position 24. You switch on multiple positions, you come over here, and you say use the block from one other position. So we want position 1 to be used in position 2, which is P2 period that we put in. Okay? This way, whenever I call this 24 position, it will automatically fall in that, and I don't have to worry about it. And that's why I set it up that way. So it sounds a little confusing, but you get it done a couple times and you'll have it. So if I do 24, actually I shouldn't have to put the block on there. It should already be in the right position. And that's what makes it work, right? That P2.1 space, and it automatically falls in that position. You don't have to do anything. It just knows. Okay, so those are the bits that you have to set up to make it right. Now, with that said, what I found was if you don't set this up right, and a lot of times what will happen is, and I've done this myself 100 times, you should put it in there, and I test it always on a 2-axis lathe. If you test this on a 2-axis lathe, it will tell you right away if you're set up properly, because on a 2-axis lathe, it'll come back and it'll say, hey, the tool didn't reach its position. And that's the clue right there that, hey, something is not at 0. And the way you can check that is by looking at this value right here, this Y value right here. And you can actually set this. You can, let's say you come in here and it's off by whatever amount, doesn't really matter. You can actually set it to 0 and it will move the tool into the right location and it will work. But that can tell you how far off you are. And basically you have to go back into the block and shift the coordinate system. Well, I would shift the coordinate system by the amount and then, put it back in. I always use the coordinate systems because I don't have to make any calculations or type in any numbers and do any of that kind of overspoke. And it works. Now, I do know that there are a few bugs in this right now. I've run into a couple of things, especially when you get into the sub-spindle side. I found a huge problem in trying to get that answered for me right now. But if you're just doing a simple one like this, that's how it works. Simple. Okay? I'll put together a small document, and I think maybe Luis has already been doing that, I'm not sure. If not, we'll get it from him to explain how this all works. But I want to just put this to bed, so it's recorded. When you guys get this video, you'll be able to look at it yourselves and go back and see what I've done. But that's how this works, okay? And there's no other way. It just works, okay? So I just want to get that put to bed once and for all. Just wanted to take 5 minutes to make sure that we're all on the same page with this. This has been an ongoing issue. It seems like in the last 2 or 3 weeks, it's like every other day I get the same question over and over again. So I thought this would be a perfect time to address it, okay? Any questions about this? I know you'll have 100. Send me the stuff.
If you're 1/10,000th off in setting up your tool position, let's say even on the first one, it's going to shift the Y-axis to get there.
Oh, this will work.
Yep.
Oh, it won't. The tolerance is like 1.5 thou. I've tested it 1,000 times.
Okay.
It's like 1.5 thou.
Now I've got a quick question. This is basically on Machine Manager. Did they ever discover what, like if you uncheck automatic tool stations, and all of a sudden you get your 12 tools show up, you're going to do 24 if you're doing the half stations, but it was populating these funky numbers in the last 5 digits of the vector.
Yeah, that's been fixed.
It has been?
Yeah.
Okay.
Yeah, that example that I showed you was all done in the latest version.
Okay.
I basically haven't worked on anything in version 14 unless you guys send me a file and I have to go backwards. But everything that I've built in the beta versions. And yeah, that stuff's all been taken care of. I don't see any of those weird. I know what you're talking about. It's like 5E dash whatever that's been solved. Okay. All right. Any more questions about this? It's becoming pretty popular for whatever reason. This turret I'm finding, especially this BT65 turret's been becoming popular all over the place. So, okay. All right. So what I'm going to do is, Daniel, if you're still out there.
Yeah, I'm still here.
Perfect. I'm going to turn this over to you and this work fixture offset stuff. Again,
sure.
we want to go back over it. I think there's been some changes in this latest build. So Daniel, if you could share your screen and explain to us again, and then we'll be done.
All right. So I want to talk a little bit about work fixture offsets. We made some changes in version 14. I think they weren't very well understood, very well communicated. I apologize for that. There were also some bugs, and there were some things that we've improved along the way to make it a little easier for your customers. But I want to start with what are the changes we made? Why did we make those changes? How do you use it, and what advantage does your customer get from it? What is it? Basically, we've changed work fixture offsets to be assigned to operations rather than being assigned to CSs. And fundamentally, that's kind of the foundation of all of these changes. We think it's important to be able to assign different work fixtures to operations in the same CS, and also to be able to combine operations from different CSs onto a single work fixture. Those are both things that customers have asked for. And I'll talk about some of the specifics about why and how, and as we go on. But first, I want to address how do I use it. So the place where you set work fixture offsets, user work fixture offsets, is now on the post dialog. So we no longer have a WFO column in the CS list. Again, this is the same in version 14. This is not stuff that's new in 2022. Instead, there's a tab in the post processor dialog. If you're using an old post, as in one that was built from the version 11 or older masters, then you'll see basically the same inputs that you would have had before. So for every CS, you can specify a work fixture offset number. That's because those posts do not allow GibbsCAM to change the numbers. So they're just reading those numbers directly. If you use a new post, you'll get a completely different interface that gives you control over which operations are using which work fixtures. And that's where the power of this really comes in. So this will display which WFO has been assigned to each operation. It'll let you change which WFO is assigned to each operation. It'll display indicators showing which kind of WFO shift is being used for each one, whether it's using the part station WFO or part instance WFO or local WFO for that operation, or one that's been borrowed from another operation. And it'll also show you whether it's at the same or a different rotation. And I'll go through all of that as we cover kind of the why you might want to do this. When a work fixture offset is shared with a different CS, you can either choose to output it shifted into that CS, or with a local origin via the use local shifts. So that would be like a G92 or similar. So if I grab one that actually has, so local shifts is a post option also. So if you see that grayed out, it's probably because your post doesn't support local shifts. But if I pick one that does, and then borrow a work fixture from some other operation here, I'm going to reset this in a minute. You can see that this little plus sign means that this is outputting a different origin. So this operation was programmed at one origin, it's being outputted at a different origin. And I can do that either by shifting the toolpath, which is what it's going to do in this case, or if I check use local shifts, you'll see the little plus goes away because this will be output as a G92 in that origin. Okay, so let's talk about this part so that you understand what I'm talking about. And then we'll talk about what the advantages are here and what you can do with this system that you couldn't do before. So this part has 11 holes in it. There are 8 in the top. The first pair of holes has their own CSs. So here's hole 1 and hole 2. You can see each of them has their own CS. Then we have holes 3 and 4, which have their own CS, or no, these are sharing a CS. So we have CS5 is being used by both of these holes. Then holes 5 and 6 we have separate CSs, but they're coincident, so they're at the same origin. And then holes 7 and 8 are filler. They're to make sure I have enough WFOs to run over the limit in a future part of this. But they each have their own CS. And then holes 9, 10, and 11 are on this side. Holes 9 and 10 are in the same CS, but they're at different solutions. So you can see from our interop toolpath here that we're actually choosing different solutions here. We're rotating the part in a different way, even though these are programmed in the same CS. And that's easy to accomplish with Op Manager or with one of the other mechanisms we have for solution selection, or it might even happen to you accidentally. And that's going to be really important as well. And then Op 11 is using the same solution as Op 9, but it has its own CS. Okay, so that's the part we're looking at. So the advantage of rescoping WFOs to operations instead of CSs means we have a lot more flexibility in how to assign the work fixtures on this part. And I'll go through some of the common cases. So let's say I have a B or C style post. So I have WFO support here, but what I want is D style output. For whatever reason, sometimes I want output that's all in a single work fixture. Previously, you would have had to have a separate post processor for that. Now you can just check one work fixture per part, and you've immediately dropped into G54 mode. So everything is G54, and you're now doing D style output. So just one checkbox. Or let's say you have ops in a couple different CSs, but you want to output them as a single WFO. So you want to conserve some WFOs on your machine, or you've used different CSs for a programming reason, but you don't want them output differently. So like these holes 1 and 2. So these have different CSs, but if I want to use the same work fixture, that's not a problem. So I can just set them both to G55, and now they're being output in the same work fixture. Okay, now that'll change the coordinates that are output for this hole. It's no longer going to be at 0, 0. I programmed it at 0, 0 in its CS, but because I'm borrowing the work fixture from a different op, it's going to now be at 0, 50. I think they're 50 millimeters between them. And that's exactly what you want in this case. Okay, so the operations will stay in the same place, even though you're sharing a work fixture. If you tried to do that in GibbsCAM 13 by assigning a user work fixture number, it would have moved the operation. So it still would have output at 0, 0, but it would have been in the wrong work fixture offset. So you had to be really careful not to overlap your user work fixtures. Here, we know what the coordinates of each work fixture offset are, and that allows us to safely combine them. Let's say you've programmed ops in more CSs than your machine has WFOs. So the posts that I've used so far here have had enough WFOs. So in this case, this Haas post, I can use G54 through G59 and also G110 through G129. But if I didn't have that, like let's say I have this post here, here I have only 7 work fixture offsets, but I actually need 8 to give each operation its own. So we'll automatically combine them. In this case, we've actually gone all the way back to D style. But if you want some of these ops in their own work fixture, you can do that. So if we apply a single WFO to all the ops on this part, okay, now we've basically taken control of the work fixtures. So these 3, you can see by this icon here, are at a different rotation. And so you probably don't want those on the same work fixture. Maybe your machine has dynamic WFOs and that's okay. But if it doesn't, you probably don't want them on the same work fixture, because then your setup information has to be exactly right. Okay, instead you can set them up on different work fixtures. So I can put this one on G56, I'll put this one on G57, I'll put this one on G58. Now, even though I didn't have enough work fixtures to program this part, I can safely assign a bunch of ops, all of these ops on the top surface, I can just throw into one work fixture offset. So during programming, I didn't have to know that. I didn't have to keep track of how many CSs I had and make sure that all the ops are done in the right CS. I don't have to go back and redo ops in order to shift machining CSs. I can do it right here as I load the posts and I see that I don't have enough work fixtures. I can go assign these. Okay, so it really does give the user control over which work fixtures are going to end up being used. Now let's say we have ops that are in a single CS but are at different rotations. So this might happen if we have a 6th axis. Say we have a 6-axis mill. The 6th axis might be at a different rotation, or it might happen because of a different solution selection, or because of a 4th axis shift. There are a number of different reasons that you might end up in that case. In this case, I have 2 of these operations, op 9 and 10. They're the same CS, but they have different solutions. And so if I go run this in Machine Sim, you can see exactly what I'm talking about here. So these holes in the top are fine. This is hole 9. Hole 10 is in the same CS, but it's on the other side. So obviously, if you try to use the same work fixture for that, and again, if you don't have dynamic work fixtures, you're going to have a big problem. That's going to result in a machine crash or some other problem. It might be an out of limits error. There are various things that it could do, but none of them are good. You don't want your operator running into that. You want to catch it at programming time. In this system, that's handled automatically. So we will automatically give them different CSs. Let me move back to one that actually has enough. So if I set this all to automatic, you can see that these 2 operations, even though they're programmed in the same CS, 9 and 10 are in the same CS, but they've been given different work fixture offsets. And that's because we know they're happening at different angles. So we can safely assign them to different work fixtures, and you won't have any problems on the machine, assuming you convey to the operator that they need to be set up that way. Now let's say we have ops that are programmed in a single CS, but we want to shift them independently on the control. Like let's say we're probing, and we've got some boring operations, and the position is important relative to some feature that we're probing, but not important relative to each other. Okay, so in this case, I've got ops 3 and 4 that are sharing a CS. But if I want them to be using different work fixtures so that I can shift one of them, that's easy enough to do. I can just grab this one and assign it to a different work fixture number. So now I'm using G57 for op 3. I'm using G58 for op 4. Even though they're sharing a CS, they don't have to share a WFO. And that can be really valuable if you need to tightly control tolerances based on probing existing features on the part. Similarly, if you're dealing with multi-part setups and you want some ops running the same WFO across all parts, and you want others done locally per part, again, because you want to say do a face milling op across multiple parts, but you have certain operations that need to be done relative to that part's origin, that's also not a problem. You can do it the same way. You can just reassign the work fixtures from those operations. The other thing that this gives you is an immediate insight into what work fixtures are going to be used on the machine. So rather than having the WFO column that says 1, 2, 3 and not knowing what that means on the machine, here you can actually see, because we have the post loaded, you can see this is G55, G56, G57, and exactly what that's going to mean. And you can also see which machine orientations map to which work fixture offset and which operations are going to be sharing WFOs. So that's all this information tells you. These are the actual orientations you're going to get. Previously, you would have had to post it out and look at the posted code to see what the orientations were for those WFOs. And if they are shared, it's now visible. So if we put these 2 ops that have different solutions on the same WFO, you can see I have an icon here that tells me that this op is borrowing a work fixture from an op that's programmed at a different angle. And so that should be an immediate indication, if I don't have dynamic WFOs on this machine, that I'm going to need to change the program, okay, because this is not safe. Or I have to be very careful with my setup data and make sure that all my offsets are exactly right. So we launched this with version 14. There were a few shortcomings in it, and we've done what we can to address those. So there were a number of bugs. Those have been corrected. So if you had some early experiences with it where it was doing things that were unpredictable, those have been resolved. We've also added this lock feature. So if you want an op to maintain its work fixture through program changes, you can now lock it. So we can just, we can lock these, and then we can move these ops around, for example, and it will not change the work fixture that's assigned to those ops. The op will kind of hang on to its work fixture offset. And that's important if you need to then reprocess that operation at a later time, or reprocess the part at a later time on the same machine with the same setup. That also allows you to reserve certain work fixtures for certain operations. So the ability to lock down a work fixture makes a big difference in terms of usability. The other thing we've done is we've added a work fixture drop down to the by WFO page here. And you can see that this page just lists your work fixtures and then which operations are sharing those work fixtures, as well as the information about the offsets. What these drop downs let you do is renumber your WFOs. So, if I, for example, knew that G55 was in use already on this machine, I could move it off of G55. Obviously, I would need to turn off automatic in order to do that. There we go. So again, now I'm not using G55. So if that's in use by some other program or something like that, this gives me a fast way to just renumber a work fixture. And that was something that was missing from the original implementation that we have now added as a web update to version 14, and is also present in GibbsCAM 22. And I think that'll make a big difference for usability in this case. So those are the two big new features that we added during the course of GibbsCAM 14, and we've also fixed a number of bugs with it. We're still working on it. There are still some extensions that we'd like to add. I'd like to make it so if you double click an operation, we load that operation, so you can see which operation, what toolpath is associated with the given work fixture. I think that would be handy. I've also proposed a way to reserve a range of WFOs. Renumbering them is great. That's a great start, and it's something that was really hard to do before we had this feature. But ultimately, the reason a lot of people want that is because they have multiple parts that that are left set up on a particular machine, and what they really want to do is blacklist a set of work fixtures and tell us, you can assign the work fixtures automatically, but please don't use these ones. They're already in use. And so we'll probably add a feature to do that explicitly, where you could say, for instance, start at G110 for this part. Don't use G54 through G59 because those are already in use. Yeah, so that's WFOs. Are there any questions? Anybody have any remaining concerns?
I do. This is Don Casanova again. I'll just say this once and kind of leave it behind, but this is very complex and gives the user a lot of options. But it has made it very cumbersome for most of our users. I haven't had any user come back to me and say, this is awesome. All of our users are coming back to us and saying, this is really bad. It really added a lot of time and complexity to setting up our programs. Some of these guys have 200, 300, 400 operations in their programs, and they got a set of work fixture offset for every one of them. Makes it really difficult, especially because it really hadn't been rolled out very well. And I appreciate bringing that up at the beginning. The other point that I want to kind of bring up, or the other thing I'd like to ask is, since it is so complex and it has so much to it, it would really be nice and advantageous to all of us if you or somebody at GibbsCAM could do a comprehensive and a very thorough webinar or video that we can send to our customers so they can learn how to use it. They may think it's great after they know how to use it, but right now there's very few that know how to use it. And so I guess that's kind of where I'll leave it, but I appreciate you guys I appreciate you going through it this time. I'll leave it at that.
I totally agree. I mean, this is a very powerful feature. We're still working on some of the usability things, like I said. I think it can be easier to use, but I do think education is a really big part of it. And so I would like to see a webinar or something of that nature, available to all of our end users, showing how to use it. I don't know when that'll happen. That has to be arranged. But I definitely do appreciate that input, and that's one of the reasons that I wanted to talk about this today. Was I think there is a lot of misunderstanding about it. I think a lot of people don't realize what they're getting from it. They see the cost, but they don't see the benefit. And so I wanted to explain what the benefits are and how we're trying to mitigate the costs.
Yeah, and that until you do a webinar, they will not know. And so sooner than later, if it could even be done before the release of 2022, that would be great.
And Daniel, might I add something on this too? Is I think that webinar needs to be done on real world parts, because
Sure.
guys see a block with these holes. That's fine, and the way you explained it, but people need to see this stuff on real world parts.
Yeah,
to help them
I use
understand it more.
A part like this just so I can highlight exactly what the benefits are, because you aren't going to find one part that nails all of these problems.
No, right. I understand, but when you explain, like, you've got one work offset with 2 holes, and explaining that, well, you have more adjustability, in my mind, a guy's going to think, well, hell, I could do that before. You know what I mean?
Yeah. No, I get it.
Yeah. So I'm thinking, like maybe a horizontal, do it. And people are very machine specific. It's amazing how, even though the software works the same in rotation, if a guy's got a vertical with a trunnion on it, he doesn't see it the same as a horizontal. So I think you need some multiple parts to go through this, and I think it would be very helpful.
Yeah, I don't disagree with that. I would say I'm not the right person to do that, but
what we're dealing with, Daniel, is 50 years of running CNC machine tools, starting back with the NC days. And we've always had a programmer process-driven approach. And this is a paradigm shift that we're trying to force onto our end users, that this fixture offset is now going to be put at the posting level. It's not the way we program parts. You may be thinking that you're programming parts in that fashion, but we have to, as programmers, instruct the setup men what they're going to touch off on the part. How are they going to fixture the part? And bang, that's what makes it all run. We don't have 10 touch off locations on parts. We don't do that. We have typically one, a primary, secondary, tertiary, bang, the parts in the fixture, go. That's the part that we need to, if we're going to sell this, we need to show the full cycle to setting it up on a machine tool and running it, and then show the benefit in that framework. And I'm not seeing it right now. And I'm not going to speak for everybody else. Let's let everyone chime in. But that's where the problem is coming from our customer base. They haven't been shown that there's any benefit to this, to that cycled process that is getting a part on the machine and running. And anyways, I'll leave it there and let someone else chime in.
Yeah, I'd say Jeff's right in that sense. This whole thing is almost like, hey, you can mindlessly program it and not worry about it to the end. But it doesn't work that way. I mean, in real world, when you're programming, you're thinking all that stuff out as you're going. And that's the one flaw I see, is that people typically don't decide all that stuff at the end of the day. It's done as you're programming.
Yeah, there's a reason why you program and you set your CS in the process, because you got it in your head and you're thinking, okay, I'm going to do it on this side of the part. I'm creating a CS in that. And then you go into the post-processor dialogue and try to remember where all this stuff is. I'm sorry, I'm not going to remember 200 operations down where that one's at. So this really, in my opinion, was a setback. And it's an option that, you know, you could have in there, but I think we really owe it to our end users to go back to being able to do a simplified version of it versus I have to go through all of this stuff now. And it puts a whole nother level of training and expertise to be able to understand this. I mean, the person that developed it understands it well because they started from the beginning, but I'm sorry, I've been programming for a long time. I'm really good at it. And this is really, maybe it's because I'm almost 60 and I'm at that point where I don't want to learn all this stuff again. And I think a lot of the end users are probably at that point too.
I think one of the important things to realize with this is that part of what we're trying to address is that exact thing that you said, which is you have to know all this before you start. You shouldn't have to know it before you start. You should be able to say, how do I want to machine this part before you need to determine how it's exactly that's going to match up to a particular machine. And that is part of what gives you machine independence, being able to run a part on several different machines, which is something that happens in the real world. I think that's important. I think it's important to understand that this is actually saving you mental effort, in that, when you're setting up your CSs, set them up for the things that you actually need. Where are the origins that you actually need? Where are the orientations that you actually need? Don't think so much about the machine at that point. Because if you do, then you have to think about it twice. By separating that out, you actually make programming easier.
Well, that's fine. And that would certainly be something that could be addressed in a very comprehensive video or webinar. Video would be great, because then we could just send it to the customers and here, study this, and then, give us a call if you have any questions.
Well, we can do that. I mean, it's just a matter of, putting some time together, and I can get together with Daniel, and we can put together something really nice. We can do that.
Yeah, I know my customers, or our customers, would certainly appreciate it.
Well, let us talk about it, and we'll try to get something as quick as we can. A lot of things going on, so we'll see what we can do for you.
Yeah, appreciate it. Thanks.
No worries. No worries. Okay, any other things that we need to talk about? We have reached our 3-hour time, so I appreciate everybody sitting around listening to us. There's no other questions or comments. I think this was really good. I think we're going to have a really nice release. Actually, when you get this beta version, if you don't already have it, it's actually pretty solid and stable. You should be able to get through it pretty good. Okay? All right. Well, with that said, that's all we got. If there's no other questions, thanks for joining us. We're going to put this recording up as soon as I can get it downloaded. We'll get it posted on the YouTube channel or wherever they put it, and you guys can go back and look at it. Yeah. Okay?
Thank you very much.
Any other questions?
Thanks, guys. Everyone.
Thank you.
Cheers. Thank you.
Thanks, guys.
Bye, everyone.
Thanks, Steve.
Thank you. See you.